Dear students, in this session we are going to see about the problems in the electricity unit. So this session covers only the problems based on the electric current, electric potential, the resistance and Ohm's law. First we see the first problem. A current of 0.5 ampere is drawn from a filament of electric bulb for 10 minutes. So the bulb is glowing 10 minutes. The current flow in the bulb is 0.5 ampere. So find the, what is the question? Find the amount of electric charge flows through it. They are asking that what is the Q value. So whatever the problems is given in problem solving, it is simple thing. First you have to write the given data and find out the formula, substitute the given value, we get answer. So the first step is write the given data. So what is the current? The current I is 0.5 ampere and the time taken is 10 minutes. So whenever the physics problems are solved, you should write all the physical quantities only in SI units. So the SI unit of current is ampere, the SI unit of time is seconds. So we have to convert this 10 minute into seconds. So 10 into 1 minute is 60 seconds. So 10 into 60, 600 seconds. So what is the question they are asking? That charge. So we have to find how much charge. So first you have to think about that. So I given, T given, what is Q? What is the relation between these three physical quantities? Means very simply, easily we can find that the current I is equal to Q by T, the rate of flow of charge. So Q is equal to I into T. Merely substitute this I value and T value 0.5 and 600. We get the answer. Charge Q is equal to 300 coulomb. Dear students, so whenever the problems are asked, the SI units are very important. Most of the students are solve the problem clearly, but they are forget to write the SI unit in the answer. So you have to write the SI unit correctly in the answer also. So next problem. So the how much work is done in moving a charge of 2 coulomb across the 2 points having a potential difference 12 volt. So the in between the 2 points the potential difference is 12 volt and the charge is 2 coulomb. So this is the definition of the potential, the amount of work done to bring a charge from one point to another point. So that work done we have to find that. So Q given, potential given, so what is W? So easily we can find the formula, potential which is equal to work done by charge, so work done which is equal to potential into charge. So 12 into 2, 24. What is the SI unit of work? It is joule. So we have to write work which is equal to 24 joule. So these two problems are examples problems given in our book. Now I take the new problem. It is what is the potential difference between the two conductors of A and B shown below. That is, they are giving the two potentials. So potential conductor A and conductor B having the potentials minus 700 volt and plus 1300 volt. So the question is, if the conductors are connected by the length of wire, which way will the electrons will flow? When the conductors are connected by the wire, which way the electrons will flow? So already in many students ask one question. So the how sir electron will flow from high potential to low potential or low potential to high potential, sir? Very simple. From in a circuit there is a battery is given. So the battery positive is a high potential terminal, this is a low potential terminal. So the electron will flow from negative terminal to positive terminal. The electron flow is in this direction, but the current flow is in this direction. So the current will flow from high potential to low potential, the electron will flow from low potential to high potential. So students are very clear. So the electron flow from the negative potential to positive potential, low to high. The current will flow from high potential to low potential. Yes, come to our problem. So from where to where the electron will flow? So which way will the electrons will flow? Means electron will flow from negative potential to positive potential. The current will flow from positive potential to negative potential. So the next question is, when will this flow of electron will stop? Yes, the flow of electron will stop when the potential between these 2 points end A and end B potential, if it is becomes same. So if there is a no potential difference, the current, or that means the electron will not flow. The current or electron will flow until both the terminal has same potential. So there is one question asked generally. What is the device used in a conductor to maintain the potential difference? So in a electric circuit, which is the device used to maintain the potential difference? Yes, this battery will continuously maintain the potential difference. So it is a 1.5 volt means continuously this battery maintain the 1.5 volt difference in the circuit. So if it is connected 220 volt in our domestic home appliances, we are applying only 220 volt. So for this our home circuit, 220 volt potential difference is maintained by the at potential. Yes. Now you see the next question. How much current will an electric bulb draw from a 220 volt? That is to a bulb 220 voltage is supplied. So the resistance of the bulb is given as a 1200 ohm. So what is the given data? By reading the question itself, please read the question once and twice and understand the question properly. So by reading the question itself, the resistance of the bulb is given 1200 ohm and what is the potential difference given? Voltage 220 voltage. So in a given data you write voltage is equal to 220 and resistance is 1200 ohm. So what is the question? How much current? They ask what is the current value. So what is the formula for this? Yes, very good. It is a Ohm's law. So what is the relation? What is the relation between these three physical quantities means? So V is equal to IR. By using the formula V is equal to IR, I is equal to V by R, merely substitute the potential and resistance value in this formula, you get an answer. I, the current flows through the bulb is 0.18 ampere. Then the next subdivision of the same question is how much current will the electric heater? So in the 220 volt, the same 220 voltage potential difference instead of electric bulb. Now the electric heater is connected, but the resistance of the bulb and the electric heater are different. For the bulb, the resistance is 1200 ohm. For the electric heater, it is 100 ohm. So the same question they are asking that what is the current? So when the current the same formula we have to use that I is equal to V by R, 220 volt. This is the resistance of the heater. We get 2.2 ampere. So this is I will clearly explain that one more thing. So for the heater it is used to heat the water. So it is an electrical water heater coil. So the resistance is less than that of the electric bulb. So here we have to use for the electric heater the formula H is equal to I squared RT. That means the resistance is less than that of the electric bulb. The resistance is less, but compare the current. For the electric bulb it is 0.18 ampere. For that electric heater is 2.2 ampere. Hence it is a I squared. The current is squared. The heat will be produced more in the electric heater than that of the electric bulb. So this concept will be useful in the electric heating effect problems also. Keep in your mind. So the next question. The resistance of a metal wire of length is 1 meter. Yes, the length of the wire is given 1 meter. And the resistance is given as 26 ohm. The temperature is 20 degree Celsius. If the diameter of the wire is 0.3 millimeter, so the data are directly given. So the length of the wire is 1 meter. The length of the wire is 1 meter and the resistance is 26 ohm. The resistance is 26 ohm and the temperature is given 20 degrees Celsius. They will ask also they are given the diameter value is equal to 0.3 millimeter. So the length is given in meter SI unit. The resistance also in SI unit. Temperature is also in SI unit, but diameter is not in SI unit. You have to convert the millimeter into meter. 1 millimeter is equal to 10 power minus 3 meter. So 0.3 millimeter is equal to 0.3 into 10 power minus 3 meter. So what is the radius? Diameter by 2. Half of the diameter is the radius. So we can put 0.3 by 2 into 10 power minus 3 meter. So what is the question in this question? It is a given data. The question is what will be the resistivity of the metal at that same temperature. So the temperature is given that it is at the same temperature. It is a extra data given. Don't confuse with this extra data. So by seeing the given data we can easily find that R, radius, L. So the radius is given for the area. Yes, the resistance formula R is equal to rho L by A. The area which is equal to pi R squared. R is a radius of the wire. Substitute that. We have to find only the resistivity. So the resistivity, keep it at the same side. Bring the remaining terms to the resistance side. So R A by L. R is a resistance, A is the area of cross section, L is a length. By substituting all the values, resistance is equal to 26 and pi, area is a pi into R. R is the whole term, the whole squared divided by 1, because the 1 is the length of the 1 meter is the length of the wire. By multiplying these are all the things, we get 26. So this simplification is very easy. The students are doing very urgently the wrong calculations. First you substitute that 26 into 3.14, 26 into 3.14. Here it is given 0.3 by 2 the whole square. So 0.3 into 0.3 by 2 means it is 2 into 2, 4. And 10 power minus 3 the whole squared is 10 power minus 6. So it is 10 power minus 6. Denominator it is given 1. So it is into 1. So by solving these equations we get the answer. The resistivity is 1.8369 into 10 power minus 6 ohm meter, because the SI unit of resistivity is ohm meter. This is also our book example problem. Our book example problem is a 4 ohm resistance wire is doubled on it. Calculate the new resistance of the wire. So very simple. The 4 ohm resistor has a length L and area of cross section A. So in the question, read the question carefully. It is doubled on it. Doubled on means they will fold on it. So if they are fold, half of this means the length will become half and the thickness will become 2 times. So 2A and L will become L by 2. So before folding the resistance is 4 ohm. After folding that, doubled on it, what is the new resistance? That is a question they are asked. So we know that R is equal to rho L by A. The resistance value before the doubled on it is a 4 ohm. So new resistance R prime, which is equal to rho into, instead of L we have to substitute L by 2 and area 2A. So this 2 will become in the denominator. 1 by 4 is equal to rho L by A. So the rho L by A is a old resistance before doubled resistance, that is R. So substitute this R value here, we get 1 ohm. This is the new resistance of the wire after doubled on it. The last problem on this session is a copper wire has a diameter 0.5 millimeter. The diameter is 0.5 millimeter. So you have to convert into meter into 10 power minus 3 and the corresponding radius value is d by 2. So 0.5 by 2 into 10 power minus 3 meter. Then the resistivity is 1.6 into 10 power minus 8 ohm meter. So the resistivity also write in the given data 1.6 into 10 power minus 8 ohm meter. And what will be the length of this wire if the resistance is 10 ohm? So if the resistance is 10 ohm, what is the length? So it is a very easily we can find the formula. We have to use only the formula R is equal to rho L by A. L is equal to RA by rho. By substituting this area value pi R squared, pi into R value is 0.5 by 2. So R squared means 0.5 into 0.5 into 2 into 2, 4 into 10 power minus 6, because it is, we can write 10 power minus 3. So 10 power minus 3 the whole square is 10 power minus 6 divided by the resistivity value 1.6 into 10 power minus 8. So we get, by solving these equations, we get the answer. The length is 1.22 into 10 power minus 2 meter. So in the same question, they are asking the another subdivisions. How much does the resistance will change when the diameter is doubled? That is, if the diameter is doubled means if D is equal to 2D. So D is equal to 2 into previous one 0.5 into 10 power minus 3. We get the answer. Diameter is 1 millimeter. So the radius will become D by 2. That is 1 by 2 is a 0.5 into 10 power minus 3 meter. The same formula R is equal to rho L by A. So that is the question they are asking, that how much the resistance will change. So the resistance only we have to write here. So R is equal to rho L by A. Substituting all the equations, we get the answer 2.48 ohm. So students, observe the simplification very carefully.